Well, the lab is all cleaned up and empty, and I'll tell you what, there's nothing that makes me feel nostalgic for the days of normal teaching, like being in an empty lab without you guys here. But anyway, here's our first video lab on simple machines. First of all, let's take a quick survey. We have a string tied to a wheel. The axle of that wheel is a screw which pulls on this string, which will lift that weight. So that's kind of a Rube Goldberg sort of contraption. We're going to pull that over here. And then the next thing is our look at what good are pulleys. So we actually have 3 of them here together, and we're going to demonstrate that you can actually get mechanical advantage with pulleys even though they're a 1-to-1 ratio. And lastly, we're going to go with a ramp. Nice, simple, easy thing to measure. So let's start with the weird Rube Goldberg looking thing. If we take a knee here, we can see that the weight is at approximately 52 centimeters. And now I'm going to grab this string, and you can see we're starting at the beginning of the meter stick, and we go 1 meter, 1.5, and 2 meters. We set the knot down at 2 meters. We'll go back and take a knee again, and if I can get that to focus, you can see that the weight has moved a bit. See those numbers there? There it is, 54 centimeters, maybe a whisker more. So now, really quick, I'm going to wind this back up a bit, and we're going to check that force reading on the little spring thing. So, how much force does it take to pull that weight? There's the numbers in focus, and it looks like you can see somewhere right around 4 or 5 newtons, whereas that weight, being 1 kilogram, is about 10 newtons. Okay? Next, compound pulley. Including the lower pulley, that weight is about 7 newtons. And we're just going to check how much it takes to move it. The force to lift that 7 Newton weight is only, see those numbers? Wow, it's easier to see in person. I can tell you that that is reading between 2 and 4. Right around 3 on average. Now, check this out. If I put the knot for the pulley at 40, then the weight is at 14, and now I want to raise the knot to 80 centimeters, and you can see that the weight is now swinging a little bit at 24 centimeters. So the weight went from 14 to 24 when the knot went from 40 to 80. So that gives you a distance ratio to work with. Lastly, we have the ramp. You can see that it's starting just a whisker over 20 centimeters. And when I move it to the top of the ramp, you can see that it's just that same whisker over 60 centimeters. Meanwhile, if we go with that top corner of the block, you can see that that's approximately 10 centimeters, maybe 10.5 off the table. And when I go to the top of the ramp, you can see that meter stick in the background that it is now at at just about 24 centimeters off of the table. Meanwhile, we're going to measure the force. That block weighs about 6 newtons. And I'm going to pull on this string, and we're going to see if we can read these numbers. And it looks like somewhere around 4.5, right? Peaking between 4 and 5. So that's all the data you need. For the first part of the lab, I want you to calculate the ideal mechanical advantages, and then when we've had a chance to talk about it, you'll calculate the actual mechanical advantage and the efficiency of each of those 3 machines. All right, that's my lab. I will be uploading this to YouTube shortly, hopefully. Thanks.